This is the first part for chapter 24 on lipid metabolism. So the pathway of dietary triacylglycerol is not as straightforward and simple as the one we learn about carbohydrate. So be able to list the step of the digestion and their transport into the bloodstream. So when you look at this here, and that diagram really helps you understand and kind of visualize and memorize that pretty well. You start here with eating. Any triacylglycerol present pass through the mouth and change, and they enter the stomach. Here, the heat and the churning action of the stomach help to break away triacylglycerol into smaller droplets. Takes longer than the physical breakdown and digestion of any other food in the stomach. That's why if you have a meal that is rich in fats, that's going to take more time to digest and you feel a little bit, kind of dizzy and need to rest. No catabolism of triacylglycerol takes place in the stomach, only preparation for this step by breaking the fat into microscopic droplets. The same way if you have a bottle with oil or fat and water and you shake it up, it makes those droplets. Now remember, those triacylglycerol, they are not water soluble, but they still need to enter an aqueous environment. Aqueous means that it contains water. So they're going to be packaged in what we call lipoproteins, which are droplets of hydrophobic lipids surrounded by phospholipid, protein, and other molecules that have their hydrophilic, loving the water, ends to the outside side. Lipoproteins are a special form of micelles, and this is just here one example. Just look at the structure. You have phospholipid, you find some cholesterol, you have some proteins, and then you also see here the triacylglycerol and the cholesterol ester. So when the food leaves the stomach, it will go through the duodenum, triggering the release of pancreatic lipase. So pancreatic comes from the pancreas, lipase is an enzyme, ASE, that helps for the digestion of lipids. The gallbladder releases the bile that was formed into the liver, and that's a mixture of cholesterol, phospholipid, and bile acids. That's the job of the bile acid and the phospholipid to emulsify those triacylglycerol by forming those micelles. So when you look at this here, it's a summary. I don't ask you to know everything, but see here, pancreatic lipase partially hydrolyzes the emulsified triacylglycerol, producing mono and diacylglycerol plus fatty acid and a tiny bit of an amount of glycerol. That's what you have right here on that figure. Now, this glycerol as well as the small fatty acid are absorbed through the villi. So one villus, many villi. Those are the very, very tiny folding that exist in the small intestine to increase the surface area. And then they are carried by the blood to the liver, and that goes through the hepatic portal vein. The ones that are water insoluble, so the acylglycerol, or other larger fatty acid are again emulsified, and then they will go through an absorption by the cell lining the intestine. To enter the aqueous bloodstream for their further transport, they are packaged into lipoproteins known as chylomicrons. Those chylomicrons are going to go through a different route. They are absorbed into the lymphatic system, which is pretty much parallel to the blood vessels we described earlier, and those are called the lacteals, very tiny vessel, pretty much similar to the capillaries that have many villi for the vascular system. They are carried to the thoracic duct where the lymphatic system empties into the bloodstream, and at this point lipids are ready to be used for their energy generation or for storage. From the thoracic duct, the chylomicrons are carried directly to the liver, and this is the slide that you should really understand because it shows you here those foldings are the villi. You see the acylglycerol, the free fatty acid, the partly hydrolyzed phospholipids. All those will be carried through the chylomicron as well as some cholesterol, and it will go through the lacteals. to the bloodstream eventually, but they go through the lymphatic system. And then the smaller free fatty acid and acylglycerol and glycerol, so the ones that are very small molecule, can actually go into the capillary to the bloodstream via the hepatic portal system. Now, of course, eventually lipids must be transported in the blood in an aqueous medium. Keep that in mind.